Okay, hi everyone. Welcome back to my channel. I'm Dr. Jodhpal Singh, and today I wanted to discuss altitude and specifically how altitude exposures can influence human physiology. And even more specifically from there, I want to identify some of the cardiovascular metrics and some of the cerebrovascular metrics as well that can be altered in areas where oxygen levels are lower or oxygen availability is more restricted. Um, these are also called hypoxic conditions. And, from there, I want to discuss a few experiences I've had from which, me being there, I can understand certain changes that were happening to my physiology because of the altitude. And there's a few other fun examples I wanted to go through as well. Okay, so let's start with defining altitude and, trying to figure out what altitude even is. So essentially, altitude refers to a specific amount or relative increase above sea level. Okay, so the higher we go from sea level, there is less and less oxygen. So from there, we can identify altitude, right, as a certain level above sea level in which there is a reduced amount of oxygen depending on our altitude level. So, if you look at some of the data, roughly every 300 meters or so, you go down about 0.7 to 0.8% oxygen. But this also depends on a number of other factors, like where you were initially, what is your reference level for defining the altitude, and so on as well. So again, essentially, as we go higher up, the less oxygen we have available for our body to use for, providing different organs with nutrients, for metabolic activities, and really for overall physiological functioning. So not only is oxygen levels decreasing, but the air pressure also changes as we go into altitude. More specifically, our air pressure is defined by altimeters. And altimeters are, essentially devices which measure atmospheric pressure. So, it's essentially like a barometer that has a calibration which is more nonlinear. Again, just because air pressure changes are nonlinear as well, right? So when you take a look at the barometer with that kind of preset calibration, it allows you to essentially measure the pressure depending on the altitude from there as well. It's available in many different aircrafts, right? So, if you're flying, even just remotely, there's a good chance that you'll have an altimeter in there as well. But, again, with air pressure, it's really a nonlinear method. Um, about 50% altitude, about 5,000 meters in altitude, you're going to drop roughly 50% in air pressure, but it doesn't mean that, every 1,000 meters you're dropping 10% or anything. It's a very nonlinear response from there. Now, air temperature is also very interesting, like often you take a look at a mountain, and at the very top you'll see that there's snow at the mountain, at the peak of the mountain, even when it's relatively warm at the base level. And the whole idea is because air temperature essentially drops as altitude increases. So the higher up we go, the colder it gets. Again, in the simplest way here that we could try to describe it is because heat is essentially generated by vibrations of molecules. So, the more molecules that are around you, the more vibrations which are occurring, these molecules tend to bump into each other and collide. And then this collision and bumping and vibration activity seems to be what produces heat. Because air expands, the higher up in altitude as we go, the pressure drops and we have fewer gas molecules in this case as well. And because we have fewer gas molecules, so fewer nitrogen, oxygen, carbon dioxide molecules, there's a less chance that these molecules are going to be colliding and bumping and vibrating as much and all that. So essentially, you're limiting heat production that way because of the reduced amount of air molecules and lack of thermodynamic activity at that point as well. Okay, so what kind of changes do we see when we're at altitude? We can go back to the cardiovascular autonomic nervous system functioning, which we've spoken so many times about. And essentially, as we go higher in altitude, we know that there's less oxygen available. So right away, you're going to get a decrease in blood oxygen saturation. And this decrease requires your body to adjust its function to make sure you're still trying to get as much nutrients that you can to your vital organs, right? To make sure everything's still responding properly. Um, and this amount of stress that's put on your body from lack of oxygen or limited oxygen can actually put a major amount of stress on your heart as well, because it has to pump the blood which carries the oxygen. And it does increase the level of stress that your heart is actually exhibiting as well. Specifically, when we take a look at something like heart rate variability, and that is the amount of variation that occurs from one heartbeat to the next, you usually want to see quite a bit of variability, right? So, in a minute, if your heart rate is 60, sometimes it might be 80 in one beat, sometimes it might be 50 in another beat. It depends on your breathing patterns and your stress levels and what you're doing. Like, there's a lot of variation that goes into measuring your heart rate. And generally speaking, the more variation you have, to a certain extent, of course, the healthier or the less stress that your heart is under. So when we hit a condition where we don't have as much oxygen available, this ends up putting the heart into quite a bit of stress. Our body goes into more of a fight or flight mode, and that essentially kicks in our survival mechanism, right? So we tend to have depressed or lower variations within our heart rate. So we have altered heart rate variability. That would be one beginning assessment to take a look at if you're ever exposed to altitude. Take a look, how is your heart rate variability adjusting? Is your heart under more or less stress? And if your overall body's feeling like it's more inflamed, it's more under stress, you can get a good estimate usually from your heart rate variability as well. So if we consider chronic exposure, let's say your heart rate variability stays depressed while you're in altitude for quite some time, that can put a ton of stress on your body. And this excess amount of stress can be measured through, again, your heart rate variability, but it also puts you in a condition where you're at a heightened risk for some kind of altered cardiac event to occur. Or even some kind of altered adverse event to occur in general, right? So that's where, if you're seeing high levels of stress on your body by measuring your heart function, it would be something to take into consideration to make sure it's not getting worse over time. Quite often in chronic exposures, though, you do tend to adjust quite a bit. So if you're in altitude for, a year or so, there's a good chance that your body's mechanisms will adapt and adjust to your environment. As an example, if you look at places like Tibet, right? In Tibet, the individuals there, they tend to not have poorer heart rate function or heart function than individuals who aren't at that kind of altitude. It's just they've been there for so long, their bodies and mechanisms have adapted to that environment. So it's quite different from that sense. Acute exposure is also really important. If we take a look at even 30 minutes, right? So this is actually a study we did in our lab over here where we took individuals, we put them in a chamber where it replicated about 2,000 to 3,000 meters of elevation, roughly 14 to 15% oxygen. And it was very interesting because we measured them for half an hour outside before putting them into the chamber. And then in this reduced amount of oxygen, we found that there's immediate depression of heart rate variability. So within half an hour, we see adjustments that are occurring as well. Blood pressure increases as well with altitude exposure. But actually, blood pressure almost seems to be a secondary product of adjustments in heart rate, of adjustments in vascular responses. Other things seem to occur first, which tend to influence blood pressure. But nonetheless, we do see altered blood pressure responses as well.